This is my testing video for my AQA A-Level Computer Science major project. The first case is on startup, a cube is simulated and displayed in 3D. So let's start the program. Okay, and here we go. So on startup, we have our 3D model of the cube. This is actually a demonstration of the second case, is the whole cube being rotated when clicking and dragging the mouse. So I can do that freely and reset by double clicking the mouse. The next case is clockwise upward face rotation with the U key press. So there we go. And anti-clockwise with the Shift U key press. The next two cases are the same, clockwise and anti-clockwise for the down face. So it's clockwise with D and anti-clockwise with Shift D. Then we have clockwise and anti-clockwise of the left with the L key. So clockwise rotation with L, anti-clockwise with Shift L. Same for right, clockwise with R, anti-clockwise with Shift R. Same with F, clockwise with F, anti-clockwise with Shift F. And then the back face, so clockwise with B, anti-clockwise with Shift B. The next case is that the controls are displayed on screen as constant text. As you can see on the left and right here, has all the controls of the individual faces, and to make it more compact, just this little bit of text to show that it also does anti-clockwise rotations. And we have the other controls for the functions that aren't individual face rotations. The next case is the random shuffle function, which you can see here is controlled by clicking the S key. The testing case should result in a shuffle being generated and executed and applied on the cube. So here we go. There's one key press of S, generates a shuffle of 25 moves, which is then applied to the cube. The next handful of cases are to show the animations of each individual face, which I did demonstrate earlier, but I'll demonstrate again specifically for this case. The upward face is fully animated for every move, and you probably saw in the shuffle that it also animates in algorithms as well. So the upward face is animated, so is the down, the right, the left, the front, and the back. The next case is this solve after the automatic shuffle. So on the key press of the /, the cube should reset to the solved state. And there we go. So that is completely solved on one key press of the /. The next case is to show that the animation speed for the solve is faster than the animation speed for any other user input or algorithm. So as we can see here, the animations are all at a set speed, and if I do the shuffle, the animations are still the same speed. But when doing the solve, they should be faster as such. The next handful of cases are to show the pruning in the solving algorithm. So the first case is that user inputted pair of moves will cancel and be ignored in the solve algorithm. So this means that any moves that completely inverse each other will be ignored because they have no net change. So a U move followed by a U prime move has a no net change. So when I press the / to reset the cube, nothing happens because those two moves are ignored. Same thing for different cases now. So inverse 4, so groups of 2 like that, which have no net change, are also ignored. So if I press / again, nothing happens. Inverse group of 2 groups of 3, so an inverse 6 is also ignored. So if I did 3 U moves followed by 3 U prime moves, is also ignored on the reset cube key press. So that's the /. And the last case is 4 moves in the same direction, which has no net change, is also ignored on the reset cube key press. So that does nothing there. Next case is to show the shuffle notation is displayed as text on the screen while the shuffle is active. As you can see down here, the shuffle is being applied to the cube whilst the shuffle is in animation is displayed. I can do another one. Is displayed in typical cubing notation, just in case the user is interested. So we'll go back there to show the next case, which is the solve timer. After every / reset function, the last solve time of the computer is recorded and displayed at the bottom of the screen, which is here. And the timer also resets to overwrite the previous solve. So if we do another shuffle and then a new solve, it should get rid of that old timer and replace it with the new one. The next handful of cases are to show the patterns that are implemented into the program that can be applied to the cube. And to also show that they can be executed from any starting position, so that no matter what position the cube is in, if you press any of these buttons, the pattern will still execute correctly. So the first case is the checkerboard pattern from the solve state. So if we just click 1 here, with the solve state, it executes the checkerboard pattern. Now let's revert back here. And then the next case is the checkerboard pattern from the scrambled state. So if we do a scramble here, and now we click 1 for the checkerboard pattern, it should still execute the pattern correctly. And here we go, we have the checkerboard pattern. So the same types of cases for the other 3 patterns. So cube in a cube pattern from the solve state, by pressing 2 results in this pattern, the cube in a cube. And now the next case is cube in a cube pattern from the scrambled state. So we'll do a scramble and then hit 2, and we should still get the cube in a cube pattern. There we go. Same thing for the cube in a cube in a cube. From the solve state, pressing 3 should result in that pattern. Very similar, but slightly different pattern, like that. And then from the scrambled state, so we'll go from the solve state, do a scramble here with the S key, and then hit 3, and we should still get that same pattern. There we go. And then lastly, the anaconda pattern. So we'll do anaconda from a solve state with the 4 key press. There we go, nice and quick. Then we'll do shuffle and test anaconda from a scrambled state by pressing 4 again after a shuffle. Should result in the same pattern. There we go. So that shows that each pattern can be executed correctly regardless of the starting state. The last 2 cases are to show the zoom controls so that the user can zoom in and zoom out freely. This is controlled by the scroll wheel. So to zoom in, I'm scrolling up, and that zooms in quite far, and to zoom out, I'm scrolling downwards.